chemistry students. All right, I'm going to try to do a quick example from your homework just to give you another walkthrough of how to figure out limiting reactants, excess reactants, and how much excess reactant will be left after the reaction occurs, okay? So I'm going to do number 4 on your homework worksheet. So number 4 on homework worksheet, this is number 5, excess reactants. Okay, so I'm going to read you the question. It says, what mass of chromium would be produced from the reaction of 57 grams of potassium with 199 grams of chromium 2 bromide according to the following reaction? And then it says, which reactant is in excess and how many grams of this reactant are left over? All right, so I'm going to write up our equation. So we have 2 potassium plus chromium bromide reacting, okay, to form 2 potassium bromide and chromium. Okay, single replacement reaction. We've worked with these before. So now we have to figure out, first of all, A wants to know what mass of chromium will be produced, and then we want to know which reactant is in excess and how many grams are left over. So first, we're going to start with A, and we're going to take what we know, which it gave us 57 grams of potassium and 199 grams of chromium 2 bromide. So we have to go through again and figure out which one is the limiting reactant. So that's the first step. So we're going to start with our 57 grams of potassium. Okay, and you can just go ahead and put it over 1. And we have to use the molar mass of potassium, which is 39.1, to turn it into moles. Okay, our grams of potassium can cross off. Okay, now we're going to use our mole ratio of potassium and chromium, because this is what we're looking at right there. Okay, which is 2 to 1. So we have 1 mole of the chromium for every 2 moles of the potassium. Okay, now our moles of potassium cross off. We need to use our molar mass of chromium, which is 52 grams. So we have our 52 grams over our 1 mole of chromium. Okay, so now we are back into mass, which is what we wanted, and we would produce 37.9 grams of chromium if we start with 57 grams of potassium. Okay, that's fantastic. But now we need to figure out when we start with 199 grams of the chromium 2 bromide, how much chromium do we produce? So we start with our 199 grams chromium bromide. Okay, and we are going to turn that into moles. Okay, you're going to figure out the molar mass of chromium bromide. Okay, so you're going to use 1 atom of chromium, 2 of bromine, add those together, and you should get 211.8 grams. Okay. Then we're going to use our mole ratio. Now we're looking at our chromium bromide to chromium, okay, which is a 1 to 1. That makes it kind of nice. Okay, I haven't been crossing these out, but you can cross out your grams of chromium bromide there. We're crossing out our moles of chromium bromide. Now we're into moles of chromium. Chromium, and we need to take that moles, go into grams. So we're going to grab that 52 grams over 1 mole, and this is of chromium. Okay, now our moles of chromium cross out, we're into grams, and we would have 48.9 grams of chromium produced if we started with 199 grams of chromium bromide. Okay, so, whew. Now we figured out which one is the limiting reactant. We can go ahead and cross this off. This is our limiting reactant. It's the smaller number, so this is the maximum amount of chromium that will be produced because we only have 57 grams of potassium. Okay, we're not done yet. Now we need to start with our 57 grams of potassium and figure out when we have 57 grams of potassium, how much chromium bromide is actually reacts with that. So, we are going to start with our 57 grams of potassium, okay? Again, turning into moles, we're just going to do the same step that we did up here. So 1 mole of potassium over our molar mass, which is 39.10 grams. Okay, our grams of potassium cross off. Now, we're going to use a different mole ratio. We're going to use just the mole ratio of our reactants. Okay, so this one right here, which is, we have 2 moles of potassium used with every 1 mole of chromium bromide. Okay, so we're going to plug that in. Okay, our moles of potassium cross out. Now our moles of chromium bromide, we just go ahead and grab that molar mass, which you would have already figured out, this 211.8. We'll plug that in. Now our moles of chromium bromide cross out, right? So we figure out that we actually use 154 grams of, we would produce 154 grams of chromium if we're starting, hold on a second. That would be chromium bromide, sorry. There we go. That's how much we're using when we start with 57 grams of potassium. So this is how much is actually reacting, all right? So we take what we were given in the question. So in the question, it said that we had 199 grams of chromium, okay, which is what we did in this step. We started with that, all right? So we take that amount of the chromium bromide. Okay, we can subtract the amount that will be used. And that would equal 45 grams of chromium bromide. That's excess, okay, or left over after the reaction, all right? So if you were going to, that's the amount that's the amount that's like, if you had a container, that would still be in the container. So now if this was on a test, of course you would need to put boxes around everything. You need to tell me that was the limiting reactant, right? That means that the chromium bromide was the excess reactant. Yeah, so there's that one. Okay, so probably just to make it clear, you could put like the answer to A, which is what's the maximum amount of chromium that could be produced. That would be the 37.9. And then your excess, your first of all, your chromium bromide is your excess reactant, and then your 45 grams is unreacted. That's kind of what I would be looking for. That would just make it really clear for me. Okay, because there's a lot of work involved here. If we do a quiz, when you do these problems, you need to show every step, okay? Don't skip around. Make sure you're following through the whole process. After you do a couple, this will become second nature because you're just doing the same thing. I mean, you're just, you're going through the process over and over and over, so it's good practice. Again, if you have questions or comments, please let me know. I hope this was helpful.